Welcome to the Scientific Sense podcast, where we explore emerging ideas from science, policy, economics, and technology. My name is Gil Eapen. We talk with world's leading academics and experts about their recent research or general areas of topical interest. Scientific Sense is an unstructured conversation with no agenda or preparation. We cover a wide variety of domains where new discoveries are made and new technologies are developed on a daily basis. We are most interested in how new ideas affect society and help educate the world how to pursue a rewarding and enjoyable life rooted in science, logic, and information. We seek knowledge without boundaries or constraints and provide unedited content of conversations with researchers and leaders who love what they do. A companion blog to this podcast can be found at scientificsense.com, and this podcast is available on over a dozen platforms and directly at scientificsense.net. If you have suggestions for topics, guests, and other ideas, please send them to info@scientificsense.com, and I can be reached at gil@eapen.info. My guest today is Professor Bart Selman, who is a professor of computer science at Cornell University. He is the incoming president of the Association for the Advancement of Artificial Intelligence, the main international professional society for AI researchers and practitioners. Last year, he co-chaired a national study to determine a 20-year roadmap for AI research to guide U.S. government investments in AI research. Professor Selman was previously at AT&T Bell Labs. He has authored numerous publications and has won many awards. Welcome, Bart.
Thank you. It's a pleasure to be here.
I want to start with artificial general intelligence, AGI, and then go into some specific areas that you are very involved in. Mm-hmm. We are born with a machine, the brain, with 10 to the power 11 neurons and 10 to the power 14 synapses approximately, in a very messy wiring configuration, it looks like. Mm-hmm. And it comes with a good operating system, but with few apps initially, and is powered at approximately 20 watts. Mm-hmm. And it's given an expected 10 to the power 9 seconds of processing time during its life. Mm-hmm. And it seems to do some very interesting things during this time. Are we getting any closer to replicating it?
I think we're definitely getting closer. So there have been some big breakthroughs, especially in the last roughly 5 to 7 years, concerning an area called deep learning, where basically you mimic, in some sense, the ideas behind the concept of a neural net, but in a very abstract way. And it has been shown, and which was a surprise to the AI community, that if you have enough data about a particular task, so think of computer vision or speech recognition, where you can have incredible amounts of data, images labeled with what's in the image, and you give hundreds of thousands of images to a deep learning system, you can actually train and get a performance out of the system that compares to human visual capabilities, at least in certain domains. For example, face recognition. Machines are now better at face recognition, and they're called superhuman compared to humans. So there have been, sort of surprising breakthroughs, and researchers had actually not expected these developments. And this has tremendously accelerated the field. Now, what you were referring to with AGIs, artificial general intelligence, right, is the ability for the brain to handle so many different kind of tasks and situations, the enormous flexibility our mind has. That has not been reached. So what we're seeing is we're seeing specialized systems. For example, machine translation, fairly good machine translation between pairs of languages, and sort of remarkable performance.
Yeah.
But all these breakthroughs so far have been on specific tasks, and we haven't quite reach the more general level of intelligence that we see in humans. I actually think it's sort of one of the remaining big open challenges. But given the progress that was made recently and the enthusiasm and the investments in AI,
Yeah.
I suspect that we also in the next 10 to 20 years are going to tackle this general intelligence. You started off by mentioning the capacity of the brain in computational terms. That is now getting in the next 5 to 10 years for about $1,000 roughly US dollars. We should be able to buy that level of compute power that is roughly the power of the human brain. So we're getting close in that compute power, that data processing abilities. And I think with sort of the enormous push in AI at this time, we will see sort of these general intelligence capabilities also emerge.
Yeah. So one criticism of the deep learning developments that we had last 10, 15 years
Mhm.
is that the hardware, again from an AGI context, the
Mhm.
hardware of the brain appears very different from conventional computing. And the question is, can we actually simulate? And simulation is not really a good way to understand something, but can we take conventional computing infrastructure and, regardless of its power, be able to get closer to what the brain does, just by software? Or do we need some very different hardware innovation that needs to come through?
Yeah, that's a very good question. So I'm a computer scientist by background. So prizes, or one of the big, I would say, insights in computer science is what we call levels of abstraction. So you start with machine language, assembler,
Yeah.
and all the way up to higher level programming language, object-oriented programming. And so we are very used in computer science to sort of hide the lower levels and build the next level up without, I call it lossless abstraction. You actually don't lose any of the capabilities
Hmm.
when you make these abstractions. So even deep nets, although they are sometimes abstractions of neural nets, they run in the end on digital hardware, on GPUs.
Yeah.
So in my view, actually, this simulation approach is working surprisingly well, and so we will, these deep nets actually, run as fast as actual neural nets. So I think keeping sort of a general architecture, maybe specialized in GPU versus CPU, which is matrix operations versus sort of more general computing. So some specialization, but not a whole lot. But keeping this general architecture and software layers, we can simulate enough to make things work. I think a second sort of surprise of people, when they think of the brain, they say, well, the brain is this very messy, very complicated wiring, evolved over millions of years, starting with lower level animals.
Yeah.
So the brain is this very complex thing. I think one of the surprises, at least to me as a researcher, is that this extreme abstraction that computer scientists came up with, and it's basically referred to early on as the perceptron, which is a very
Hmm.
simple compute unit, which is an extreme simplification of an actual neuroscientist would actually not doesn't really consider the perceptron anything like a neuron.
Right.
But then there's the surprise that it was apparently, if you have enough data and a general learning procedure for adjusting weights, it doesn't really matter whether you had the details correct. So I don't think we need the full details of the brain
Mm.
to represent to capture its capability. And computer vision is sort of an example. We don't really replicate the human visual cortex, but our performance of our deep nets replicates their capabilities. So I think that's more the path we're on.
Yeah.
where we get inspiration from the brain, but we don't need to really model it at its full detail.
Yeah, so I think that's an important distinction, right? So if you think about AGI as, sort of a machine that out of the box does not have a specific task programmed into it, or not specializing in something, but out of the box could be deployed on something that it can learn,
Mm-hmm.
anything new.
Yeah.
And learning in this context is used very generally.
Mm-hmm.
It's unclear if the machine is learning anything, but it could
Yeah.
compute and produce something that might be useful.
Mm-hmm.
And so I guess from a mechanistic perspective, we could reach AGI, and I think it's an important distinction because we are not really trying to replicate the brain, I would imagine, right? Because we don't really have a theory of consciousness yet.
Yeah.
We don't. I don't believe we really understand what the heck is going on in there.
Yeah. No, you're very right. You're very right. And it's an interesting time because we're revisiting some of these questions. In the early days of AI, there was a lot of discussion about whether AI was possible, what consciousness is, all aspects of creativity was also a topic. Can a machine be creative?
Yeah.
Can the machine truly understand? That was another question. So these early questions of AI were discussed in the abstract, often involving philosophers, psychologists. That discussion went away, and basically people sort of went down to sort of more the technical side, and let's just produce a machine that can do something.
Yeah.
and uh, and now we've reached the stage where machines are doing interesting things, and now some of these questions are going to come back. Can we get consciousness? Does consciousness emerge out of complexity? Does creativity emerge out of complexity? For example, creativity I know a little better,
Yeah.
and I look at sort of mathematical discovery, for example. We're starting to see glimpses of kind of creativity emerge in machines. In fact, if you look at something like AlphaGo or AlphaZero, which are the Go and the chess machines based on deep learning,
Right.
they are starting to make creative moves and actually have made creative moves that people say, wow, this is a new way of looking at the game. So I think we're starting to see glimpses of, hey, maybe when we reach a certain level of complexity, things like creativity will also emerge. Now, consciousness is a whole other question,
Right.
but it's interesting that we're getting back to these questions now because these systems are finally reaching a level where these questions become relevant again.
Yeah, so that's very interesting, Bart. So,
Yeah.
if you define creativity as, sort of, if you run an infinite number of experiments on a
Mm-hmm.
problem,
Mm-hmm.
you're going to find a new way of doing something, and we could define that as creative. So, as computing resources increase,
Mm-hmm.
we may find, like you say, as complexity increases, we may find the machine is able to do a lot more experiments than a human is, right?
Mm-hmm. Yeah.
And if that the number of experiments that could be run increases quite dramatically, then we won't find a difference between human creativity and machine creativity at that point, potentially.
Yeah, that's a potential route, and so I call that sort of the performance measure of AI, where you just look at the result of the system. So in computer vision, if it recognizes faces better, that they actually done experiments where they have 100 people or some group of people try to identify images, and we have a deep net trying to recognize the faces in the images, and see that the machine is superior in that performance. So then purely at the task level, the machine outperforms the humans, even though the deep net is not doing the same kind of calculations that the visual cortex is doing.
Right.
So what you're sort of suggesting, this could happen in creativity. We would see creative mathematics being created by machines, but the underlying process might be quite different than the human brain. And of course, this is partly because we don't really know how the human brain does these kind of things. So
Right.
it would be hard to duplicate, or it's hard to duplicate, and it's hard to actually, even if we would accidentally duplicate, to know that we did. So
Yeah. And one could envision this as sort of a new species, right? So if machines really get AGI, really, we really take off in that arena, it
Yeah.
might be that, it might be considered a new species because the way
Mm-hmm.
that they approach problems could be quite different.
Yeah.
So it might add a level of diversity to
Yeah.
society that might be
Yeah.
beneficial, right?
Yeah. Oh, for sure, for sure. Actually, sort of the way I look at it is also, when we think of intelligence, we tend to think in human terms. That's the kind of intelligence we know.
Yeah, yeah,
we know our own cognition. I think there could be whole different types of intelligence out there that machines might excel at and bring in new dimensions of intelligence. A good example I can think of is we are very much restricted in our thinking to sort of at most three-dimensional things you can imagine.
yeah.
When you start talking 5-dimensional, 10-dimensional, our human brain actually can't handle it. It can't
That's right.
actually
Yeah,
can't actually think about it.
yeah,
So we can do some calculations, but it's all very painful.
right.
I see no reason why a machine could potentially not think 5-dimensional, 10-dimensional without any effort. so,
Okay.
so it may bring what I call non-human AI, non-human artificial intelligence in the picture, and by working together in sort of a collaborative manner, this might greatly extend, what we can think about and how we can understand the world by having the machines and humans collaborate. So,
Yeah.
so I like that view of it, sort of a diversity issue that could actually be quite interesting and quite positive.
Yeah, it's thinking about higher dimensions. One of the deficiencies we have is that to make it understandable, we need to map that back to our experiences.
Yeah,
And higher dimension, it's a yeah,
yeah,
it's a prototypical case of this. So, and similarly, perhaps certain aspects of physics like quantum mechanics
hmm,
where we still really haven't been able to fully appreciate, understand it. I mean, we have a lot of practical applications based on the theory,
hmm,
but a lot of physicists say they don't really understand quantum mechanics. And so this is a interesting avenue for machines, right? They may
yeah.
understand it very differently. And I think you have done a lot of work in machine reasoning, those types of
Mhm.
approaches, right?
Mhm. Yeah. Yes. Yeah. So that's sort of my main area is machine reasoning, machine inference, and there we're starting to see indeed the machine being able to, chain together, literally billions of small reasoning steps, like the reasoning steps we make when we do something like mathematics. When we prove a theorem, we take little inference steps to get to our main results. A human can do a few hundred steps, something of that order. A machine can do billions of steps.
Yeah.
So we're starting to see machines seeing, in some sense, mathematical truths that the human brain can't quite see. Now, what's interesting about the latest results in this area is that we actually can write other pieces of other code, which we call proof checkers,
Mhm.
that can actually verify the billion step proof very easily. People can agree on the proof checker being correct. There's a correctness proof of the proof checker. And so mathematicians can actually start taking these new insights that the machine comes up with after a billion steps of inference and add it to their mathematical truth. And so the mathematicians can build on it further, the human mathematicians, even though certain facts they could not themselves verify by hand
Okay.
or check. So I think we really see there the complement of human capabilities. And, I should mention the flip side, because sometimes people think, oh, machines should be much better at mathematics than human mathematicians. Human mathematicians are still a million times better than machines at
Right.
mathematics. That's actually sort of one of those. Sometimes you think AI is very far, and AI is going very fast, and very progress is incredible. in certain kinds of reasoning, and in particular, developing new mathematics and complex mathematical concepts, the progress is still very slow. It's surprisingly hard for machines to do, and that sort of brings out the human mind still has capabilities that we do not know how to duplicate, and I see that in my own area. But again, there is the other kinds of proofs that the machines are super good at, and there are proofs that humans are very good at.
Yeah, so some of the problems that you looked at, Bart, it seems that when there is a very large amount of data or complexity, and there are simple heuristics hidden underneath that, it seems like there are approaches you can take with machines who might be able to do that without an exhaustive search of the design space, right?
Yes, yeah. They actually, that's part of the surprise. So you characterize it right. So these are statements where basic inference steps, basic small steps can be taken to ultimately come to a result, a final result. But the machines can find that sequence of steps by not considering all possible sequences, just zooming in on very particular ones, and the machines are surprisingly good at that. In my class, I give an example of a proof that was done in 2015 of air dust discrepancy conjecture. It was a mathematical conjecture for discrepancy 2, and it was resolved by a search program. And I think I sort of said, if you had to draw the full search tree, which you would naively say I would have to explore all possible proofs, it would be larger than the number of nodes in that tree would be larger than the number of particles in the known universe.
Right.
So it's used. On the other hand, the machine found the proof by only looking at about 10 billion nodes. So a minuscule fraction of the full proof. So that's the surprise. Now, on the flip side, we know that the human mind can do certain abstractions and changes in representation that we don't know yet how to do. So when a human mind matches, let's say, a theorem of geometry into an algebraic form or some other mathematical concept, the humans can make these jumps that machines cannot really do at this point. So the human mind still has these abilities to make connections between disparate, distinct areas of human knowledge and map one result to another that machines are still far behind on. So that's sort of surprising.
Yeah. And as we get better and better at this, one of the fears society has is that the machine will make work obsolete. But all through human history, I would think that humans were never very good at work. If it is defined as predictable, repeatable activities. So neuroscientists and generally medical professionals think human brains sit on an ADHD spectrum. Everybody has a bit of ADHD, and perhaps for evolutionary reasons, as most of our history we have been explorers and looking for new lands and ideas. And only till very recently, till the when the desk job was invented, we went to the work paradigm. So one could argue that work is not a good thing. We should really make it obsolete. What is your view on that?
I very much sort of agree with that view. Is that our notion of work will probably change. That if machines can do sort of the mundane work, and in some sense you see the prime example. We've seen some of that. The production of food, I guess, 2 centuries ago or 1 century ago, 70-80% of people were involved in producing food, and now I think it's 3 or 4% of the population. So machines have enabled a very small group of people to produce all the food we need, and so I can see machines come and help do all the kind of 90% of all the routine work or 99%, to provide us with a fairly high standard of living for everybody in terms of healthcare, in terms of food, in terms of living, travel, and humans will be much more free to spend their time and explore their different directions and be creative, because there's certain activity you may like, art or movies or things that we produce and often involving creativity that are very much related to human, or even caregiving or being part of social groups are very human activities, and we'll just have more time for that, and so we may actually have to shift to that kind of society, or machines will enable us to do that. The big concern, I guess, from an economics point of view is who if we create large amounts of inequality, and certain people are going to own the machines. That's a whole totally separate problem that needs to be addressed. But it's not on the surface a bad development.
So in the long run, it can only be optimum if you have more advanced society with different policy perspective. For example, universal basic income may become a necessary thing in such a society, right? And so do you see that the policy aspects of this is really trailing the technology developments, and if so, that's going to create a problem, right? But I know that you were involved in sort of a roadmap for the US recently. So what are your thoughts on that? How do we get over this problem?
So it's definitely there's this policy angle. I'm somewhat hopeful because people are starting to discuss these issues. Policymakers are starting to understand these issues. Discussion about universal basic income is getting more and more attention. So I'm actually fairly hopeful that society will develop policies and regulations and frameworks to make this transition to a more automated world happening in a positive way. Now, it could go wrong, but you actually do see differences in the U.S. and Europe and China. Actually, one thing that surprised me about China is that I've met people there who were much less concerned about AI than people are in the United States, and when I asked them about that, because I was a little surprised, is they would basically say, well, the government would have to find me something else to do.
So there's a safety net. There's a safety net.
There's a safety net, and they weren't that concerned about it. And of course, in the U.S., that's a little different. So I think these issues have to be addressed. I'm somewhat optimistic because we see more discussion about it. And in terms of even inequality, when things become so abundant and everybody can have decent healthcare, you just get, an healthcare app, and then you get your doctor, your personal doctor is an AI assistant. When things become really abundant, I think it may be the case that people will be willing to have everybody access to that kind of healthcare, to give everybody access to that kind of healthcare, because it's actually not that expensive. So I'm somewhat hopeful that with the technology actually developing, it will be shared because it doesn't cost that much to share it. So, but this is the optimistic view.
I'm less optimistic about that, Bart, because if you look at levels, so we are in a society I would call sort of a level 0 society, right? And data tells us that there is an inverted U-type relationship to happiness or utility in more broad terms, and it's maximum at 75K in the US, or 75K of income. But there is nobody's subjective function that stops at 75K. Right? They are spending all their time to to do things that seem to reduce utility, both individually and for society as a whole. If you look up, environmental degradation and all sort of external costs that the society is bearing. So I don't know. I mean, unless we almost need a step function change in societal design, and I don't know how that will happen.
Yeah, no, I think you're raising a very good question. I sort of always, because I'm from Europe, I sort of look at how Europe does. They actually, put less emphasis on work. I guess put more emphasis on the quality of life. I guess so. And they have 6 weeks vacation, weekends off. They actually sort of look at the U.S. as like, why would you want to work 2 jobs?
Right.
And so I look at Europe as an existence proof that a society could actually decide, wait a minute, maybe it isn't worse to work 3 jobs, rather take a vacation. So I could see that I think Europe sort of as an existence proof that it could be done differently.
Yeah.
Now how you could bring about that in society, that's a bigger question.
It's a bigger question. And then the question is, who decides what is fair, what is ethical, how is the system governed and managed? All those questions then become very important, right?
Yes, no, that's true. And and right now I guess things are not working that well. So there's a long way to go.
Yeah.
But AI might help, actually. I think that's not one other thing. AI could potentially help. It could help make businesses run better. It could actually help organizations in sharing information better. There are actually things that AI could do, I think, that might actually help us understand each other better and understand the rest of the world better. So that's a potential positive aspect that AI could contribute to.
Yeah, so things like the investments that we have made in other areas, like the human genome, or the Large Hadron Collider, Hubble telescope, none of those actually, when people say those are good things, they don't really have a direct impact on the masses, right? Whereas here, an accelerated investment into AI would imply that it is going to fundamentally change society. So it is going to have a direct impact on individuals. And then the question is, how do they react to it?
Well, and I think what I think is a little unfortunate, the positive impact is often not sufficiently highlighted. So I think healthcare is probably the prime example. It's a very expensive commodity in the United States. It's in many ways too expensive and hard to access for a lot of people. AI could really change that. Could really make it more accessible at a higher quality for the average person. So I think what's important for a government or for policymakers to do is to actually highlight these positive changes that could happen if investments in AI are made properly. Now, interestingly, these are not necessarily investments that companies would want to make. Like companies might want to get into AI healthcare, but they get into it for economic reason to make more profits. We could benefit as a country by saying, wait a minute, we could have everybody have an AI assistant. If you live in a rural area and you can't get to a doctor, a high stakes hospital, you can get an AI assistant, give you a diagnosis that is comparable to a good diagnosis at a city hospital. So there are opportunities there. The second opportunity, I think, is often the elderly care. So for people to live longer independently, some form of household robot, which basically provides in-home care, but in-home care is an expensive proposition and it's expensive to do with human resources. A robot assistant in some form could really be a solution there. So I sort of I would hope that people see sort of the positive opportunities there of really reducing the cost of certain kinds of services that are now just too expensive for the average person. And that would make a change.
Yeah, I mean, home health is a very good example, especially if you get to a point that the robot can actually learn and understand the individual. For
Yeah,
instance, simple things like medication compliance and things like that
yeah,
are important, and we are failing in those
yeah,
simple things.
yeah, yeah.
And so the research priorities that you looked at for the US, you kind of bucket that into three different areas, Bart. So you say
Mhm.
integrated intelligence,
Mhm.
meaningful interaction, and self-aware learning. Do you want to
Mhm.
talk a little bit about what those three buckets mean?
Yes, yes. So the first bucket, integration, is really combining various capabilities that have been developed now. So let's say computer vision, speech, and planning or decision making. So these are different AI capabilities. Integrate them in a single system, in a robotic system, for example, that does perception, that makes decision, that helps if it's a caregiving robot, that observes a human being and reminds the person of medication and looks for possible problems. So integrated intelligence is referring to that integration process,
Yeah,
and it's necessary because AI has become very specialized. So there are people that spend their full career on computer vision but don't actually think about decision making, and there are people
yeah,
working on decision making. So that's the integration part. The second aspect is how we interact with machines.
yeah,
So integration. This is very relevant to the integration in society. One thing that we have to come to grips with, and will take some time, is for us to understand the machines better, what their limitations are, what their capabilities are, and vice versa, for the machine to understand the human better. And this may involve notions of trust, for example. You have to trust your caregiving robot to do the right thing. And so that's that human machine interaction, which is only has been studied for the last few years. It has come up because before that, machines were sort of separate. Robots were separate. Did not really interact with
yeah.
people much. So now we're learning about the interactions. And an interesting question. People may actually be. I see that a lot with the voice assistants like Alexa or Siri or Google Translate, where people. Oops, actually, that's my Alexa speaks up. But but people often misunderstand
Yeah.
what these systems understand. So there's also an educational process for people to realize, no, these systems have some capabilities, some intelligence capabilities, but other things they really have no clue about what's
and
going on.
the
Yeah.
interaction there goes both ways, right? So I
Mhm.
have
Yeah.
seen some experiments where the human starts to develop empathy for the machine,
Yeah. Yeah. Yeah.
and
Yeah.
any disassembling of the machine is creating PTSD
Yeah.
type issue for the human. So
Yeah.
the interaction question is really a very important one, I
Yeah,
think.
yeah, and no, it's a very important one, and I think, especially in my mind, it's because there's also a risk for sort of, abuse, in the sense of the machines, the designer of the machines taking some sense advantage of the fact that they know the human is going to show empathy. So it's
Right.
going to buy more things from Amazon because they feel they have to. So we have to watch out a little bit for that, and we have to be aware that humans are really attached to
Yes.
to machines, and machines should not take advantage of us. So
Yeah.
so
Yeah. And the
and
third bucket there is you call it self-aware learning.
self-aware
Yeah.
learning, that's a little bit of a vague term, but basically it's referring, like, machine learning is very powerful now, and the deep learning shows that. But it's all what we call learning from labeled examples. That's actually the main thing. So you give tens of thousands of images, each labeled with what's in the image, and you can learn from that. Now, clearly, that's actually not, most of our human learning actually is not done that way. We actually, when we go to school, we learn from textbooks, we learn from instructions, we learn when we reflect on how we solved a problem the last time. We think about, oh, what did I do wrong? And then we correct ourselves. So human learning is way more complex than current machine learning, and self-aware learning is partly knowing more about your own learning limitations, your own strengths, reflecting on your learning process. And so we want machines to get some of those capabilities, and ultimately we want machines that do what we call lifelong learning. So your personal assistant robot that does elderly care, that cares for a person in the house, you want that robot to learn and observe and potentially change behavior when the robot is caring for, gets a new complication or something unexpected happens. So we want machines that are more aware of their learning process and learn more like humans learn, and that's quite different from the current learning work.
Yeah. Are they going to play a major role in education, in your view?
Yes, so that's I think one of the exciting. I'm myself involved in some education work, AI in education, and the most exciting work there I see is where an AI system collaborates actually with a human instructor. So there's a human teacher in the loop, because human component is very important. The social component is important in teaching, but the AI teacher can tailor the curriculum more towards the particular student by the AI system analyzes the strengths and the weaknesses of the current student and adapts the curriculum, adapts the next exercises that should be done and the next steps that should be taken. So AI systems, I think, will enable sort of what we like to call a lifelong learning process, where you might even have your individual AI teacher that will help you, select, what skills to or what fields to learn next, and how to improve your capabilities, but in a lifelong process.
Yeah.
So yeah.
Yeah, it reminds me, but in the mid 80s, my graduate thesis was an expert system
Mm-hmm.
that was used to build up design intuition in graduate engineering students, and
Okay.
and the idea was there is a design problem. The student interacts
Mm-hmm.
with the machine
Mm-hmm.
and makes a design choice, and the machine gives a feedback to the student. Doesn't give an
Mm-hmm.
answer, but
Yeah.
gives a feedback as to which direction to head in that design space
Yeah.
to get to that minimum cost position. And by
Yeah.
repeated experiments, students were
Yeah.
able to do that. Obviously,
Yeah.
embarrassingly
Yeah.
unsophisticated.
Well, I think, but I think it was an important first step. I think we will see these systems, and actually there are people working on these kind of systems as we speak, and what they're bringing in now is computer vision, so you can actually look at the drawing the student makes, speech recognition, you can talk and hear the student. So I think the early work showed, I think, the potential.
Yeah.
Of that kind of educational system. And now with the new capabilities we have, we can design much better ones. And what always surprised me, there's often a threshold effect. I saw it myself fairly recently. I've followed speech recognition for a long time, and asking things to Siri or whatever, I always find them somewhat embarrassingly bad. Until like just a few months ago, I realized, hey, it's actually pretty good. So now I'm actually using it.
Yeah, yeah.
So I think the same thing for the tutoring system. When you worked on an expert system, yeah, it probably wasn't quite good enough to really be useful. But I could see that flip around very soon.
Yeah.
And I interact with a Chinese company, Squirrel AI, that does after-school tutoring of millions of students in China. They have encoded what they call a knowledge graph of the K-12 curriculum with millions of facts and data points encoded in a large graph, and they can track which concepts they know and which concepts they don't know, and then teach the missing concepts when they discover something is missing in the student's knowledge. So this field is moving fast in terms of education and what machines may be able to help us with.
Yeah. The dark side, of course, is that when AI gets really smart, they might just keep the humans dumb enough.
Well, yeah. So Yeah. So the AI designers have to. That's the AI and ethics angle. They have to actually put some safeguards into the systems. Yeah.
Yeah, and just like any other technology, the darker side is, the countries using it in war
Yeah.
situations.
Yeah.
So, smart weapons, and we are already hearing many of those
Yeah.
things in action already. What is your view?
Yes.
What is
Well,
needed there to assure we don't get into trouble?
yeah, so now that I think is a concern, and the AI community is trying to is actually speaking up with motions and proposals for the United Nations, for example, because it's a real concern that you could develop because AI is very much a dual use technology. You can use it for good. You can use this face recognition can be used for good to find missing children or something like that, and it can be used for bad, and
Yeah.
you know so. Um, so and especially when it comes to military applications, there are some clear risks there. What we're sort of hoping is that nations will recognize that it is in nobody's benefit to actually encourage the development of certain types of weapon systems, like autonomous drone systems that fully automatically search their targets and try to take them out. You know, there's some hope, and when we had a meeting at the White House with some people from the Defense Department,
Yeah.
they actually realized that there are actually certain risks that there may be technology we simply don't want to develop, and we want to have agreements with other countries that we shouldn't develop those technologies. So again, there I think sort of the first step is an awareness that there are certain paths that are not good for anybody, because you can say, well, it's good if we have those systems, but when we have those systems, someone else will replicate that. So so you have to sort of get an agreement of not to design certain things.
Yeah.
And yeah.
The problem, obviously, with those types of agreements, is that there's a game theory aspect to it, and
Yeah.
they tend to
Yeah.
be. I mean, we saw that in nuclear weapons.
Yeah.
These agreements tend to be unstable, and then it takes off from there. So it's
Yeah.
I think I don't know what the answer is, but we probably need a more robust worldwide policy making infrastructure for it to
Yeah.
work, I think.
And more agreements between groups of countries. And ways to enforce the agreements. I guess that's another issue.
Yeah.
The nuclear thing is an interesting example, so, because I go back and forth, and that's actually positive. We haven't seen a nuclear war, so there's something positive about it.
So that's because many countries have it, and they all know the bad aspects of pushing the button, so to speak.
Pushing the button, yes.
But unfortunately, it's in some sense it's an unstable equilibrium. All it takes is as a madman to enter one of those countries, right?
Yeah. No, that's true. That's true. It's not a very stable situation.
So in conclusion, then, Bart, if when you look forward 5-10 years, what's your speculation in kind of 2-3 areas? One is, where do you think we will be in AI, AGI more generally from a technology perspective? And number two, from a policy perspective, what are the things that we are likely to get done? What things might be sort of open. And then the third one, much more generally, do people in 5-10 years will the population in general understand the track the technology is on? I don't believe it's really well understood today. So what do you see in the next 5-10 years?
Yeah. No, so that's a very good question. So I think what we'll see is sort of a continued acceleration sort of specialized applications, I would say. So narrow scale applications, including some form of self-driving car or at least driver assistant transportation. some hopefully progress in healthcare. So people will benefit, personal assistants that are better in communicating and doing things for you. So I think that will accelerate, that will keep going and actually be further accelerated because of the large investments in the areas. I think AGI will be further off. So that's definitely, in my mind, not in the next 5 to 10 years, because there are some some fundamental things we haven't quite figured out yet, and that will take another breakthrough. So policy making, I'm hoping that at least people are starting to understand better that AI can provide positive benefits to society. I think that partly why China is so gung ho on AI is because they see it sort of as their next industrial revolution in some sense. So so we might even look at something like China and say, hey, you can really improve your standard of living in your society by adapting more AI technologies. I'm hoping that we don't have a backlash against it. That's a little bit of difficulty in the US, that people are so worried about the negative effects that they may want to stop these developments. And I think that would be a big mistake. That would be missing an opportunities, and other countries will run around us. They will, they'll automate manufacturing. They will, do things that we can't do anymore. And so it would be very bad for a country to actually say, I'm not going to pursue this dream in some sense. But I'm somewhat optimistic that, since I don't think that AGI will not happen in 10 years. It's not even clear it will happen in 20 years. So it will be more these specialized areas where it really can help us. And as long as it's limited to certain tasks, like a self-driving car, there's no real risk to that. I mean, it's just driving a car. So as long as you can make it sufficiently safe, which is the key requirement, it's going to be useful. So when we will see these emergence of translation systems, we can travel the world and just have simultaneous translation. When you talk to somebody in any country that you visit, you both be talking your own language, and you get simultaneous translation via a little earpiece. That kind of technology, I think, will be around. It's already almost here. So I'm hoping that people will see the benefits and have their own personal health assistant, and so that's how I'm hoping that AI will be integrated in society. I am hoping that politicians become more informed about it, so that people in general start getting more informed about what the opportunities are, and then there may be necessary to have some regulations. I think there have to be regulations of not one company having the whole market and those kind of things. So that's maybe another requirement we need to put in place for AI technology.
Yeah, especially on the raw material side. If one company is holding all the data, and this is a big issue for healthcare as well.
That's a huge problem.
So this has been great, Bart. Thanks so much for spending time with me, and good luck with everything that you do.
Okay, thanks so much. It was fun talking to you.
Thank you.
Okay, bye-bye.
Bye.